1572 subtree of another tree. Given the roots of two binary trees, root and subroot, return true if there is a subtree of root with the same structure and node values of subroot, and false otherwise. A subtree of a binary tree is a tree that consists of a node in tree and all these nodes descendant. So as you see in this example, we have the roots of a tree and root of another tree. This is the subroot and this is the main tree. We want to see if we can find this subtree in this tree. When we check that, you see we have 142 and we have 142 here, so we are going to return true. But what we should be careful about is like the subtree, it's a node and all its descendant, right? The root node and all its descendant. So as you see here, the subtree that we have here is 1420, but the subtree that we have here is 142 and we don't have 0. So we are going to return false for this case. The way that we are going to solve this problem, we are going to traverse this tree, we are going to traverse this tree, and we check if we can find this traverse tree in this tree. And for like simplicity, we are going to convert this tree after traversing to a string, and the same thing for this. So I'm going to have a function for DFS and I'm going to pass a node, and for traversing, in order traversal, it's going to be return, it's going to be node.val, right? But we need it as a string, so I'm going to put str here, and then we check the left side and then we check the right side, dfs node.right, and if there is a node, otherwise, because we are doing it a string, we're going to return an empty string. So let's see, based on what I've explained, how is going to be the output. So I'm going to print the DFS for the root, and I'm going to print the DFS for the subroot. Actually, it should be like this. Okay, let's print it out and see how it's gonna look like. Okay, as you see, now we have, I have two examples here, so I'm gonna put them here so you can see them. I have two examples. I have this tree and subtree and this tree and subtree. Okay, as you see here, this is the same thing. It's like 3, 4, 5, 1, 2. I have added 2, 5 too. So basically what is happening here, it's printing, it's traversing this tree and printing out as a string. And you can see that the sub tree is 412 and we have it here, and the subtree for this is 4 and we have it here. So it's supposed to return true, but this is not right way to do that. The reason is because we need to check if there are like other descendants, if we have nulls and this kind of stuff. So to deal with that, what I'm going to do, I'm going to say if there is null, I just randomly choose the $sign, put the $sign here, and for differentiated every single node, I'm going to put another, like let's say use hashtag here. I'm going to use hashtag here. So next time when I print it out, it's going to be something like this. So when we are comparing this with this, we are going to look for $sign in this tree, not just the number 4, not just the number 4 in this string. So let's see how it's gonna look like now. So I'm going to say return the DFS of subroot if the DFS of subroot is in DFS of root. Basically, I get these two strings and then I check if I can find this string in here, right? And let's run the code, and there you go, it's accepted. For the first example, it's supposed to be true because we have this sub-tree here. And for the second example, it's supposed to be false because the 4 is here, but we don't have the descendants. So the time complexity for this, I believe it should be m plus n. M is the length of the root, and n is the length of the subroot. And the reason I'm saying that, I checked the Stack Overflow and there was a post on here, and it was suggesting that since Python 3.10 that they're using the heuristic are used to lower the worst case scenario to O n plus m. And I got the idea of the solving that question from this user, that he posted his solution on discussion from LeetCode. Thank you.